Hi students, this is Alex here. In this video, we are going to find the Fourier series expansion for the given function. First thing, we have to check whether it is even or odd. So let's take our function f of x as two part. One is g1 of x, which is for minus pi less than x less than 0, and g2 of x, which is for 0 less than x less than pi. So from this first part is alone g1 of x. So g1 of x value is x, and g2 of x, the second part and the third part together, that is 0 and x minus pi by 2. If I take g1 of minus x, x is replaced as minus x, but I am not getting g2 of x. So it is neither even nor odd. F of x is neither even nor odd function. Now we are going to find a naught. The a naught is by formula 1 by pi integral minus pi to pi f of x dx. Now this is 1 by pi, and minus pi to pi is split into three parts. One is from minus pi to 0. So I am going to take that interval minus pi to 0, and that time f of x is x. So x dx. In the same way, again 1 by pi integral, second interval is from 0 to pi by 2, and that time the function is 0. So 0 to pi by 2, function is 0. Then 1 by pi integral, the last part is pi by 2 till pi, x minus pi by 2 is the function. X minus pi by 2 dx, and it is from pi by 2 to pi. Now, when I integrate the first part, x integration is x square by 2, and we have the limit from minus pi to 0. Second part is 0. Third part, x square by 2 minus pi by 2x, and limit is from pi by 2 till pi. Now when I use the upper limit, it becomes 0 minus, when I use the lower limit, minus pi whole square is pi square by 2. And here when I put pi as upper limit, pi square by 2 minus pi square by 2. When I put the lower limit, bracket open, pi by 2 whole square is pi square by 4, and already there is a 2, so it is 8. Then minus pi by 4. So we substitute our upper limit, then minus lower limit. And anyway, this we can cancel. So minus pi by 2. And even here there is 1 by pi outside. We have to take that. Then plus 1 by pi. We can cancel these two. This by taking LCM, we get minus pi square. We'll work out here. Pi square minus 2 pi, minus pi square by 8, and already there's a minus sign outside. So it is plus pi square by 8. So we can cancel these two. So finally we left with minus pi by 2 plus pi by 8. We'll take LCM. LCM is 8. This is minus 4 pi plus pi. So a naught value is minus 3 pi by 8. So we got a naught as minus 3 pi by 8. Now next part, we have to calculate an. An by formula, it is 1 by pi integral minus pi to pi f of x dx. Sorry, f of x into cos nx dx. Now this is 1 by pi integral minus pi to 0 is the first part. That time our function is x into cos nx dx, because our function is x, second is 0, for integral 0 to pi by 2. So plus again 1 by pi, we have integral 0 to pi by 2, 0 into cos nx dx, and third part is 1 by pi integral pi by 2 till pi, and our function is x minus pi by 2. So x minus pi by 2, x minus pi by 2 into cos nx dx. Now we are going to use Bernoulli's formula. So this is u and this is v. So u equal to x, v equal to cos nx. So u dash is 1, u double dash is 0, v1 is sin nx by n, and v2 is minus cos nx by n square. Similarly, here this is u and this is v. So u equal to x minus pi by 2, u dash equal to 1, u double dash is 0, and v is cos nx, and its integration v1 is sin nx by n, and again v2 is minus cos nx by n square. And we are going to apply the Bernoulli's formula, which is u v1 minus u dash v2 plus u double dash v3 dot dot dot. So in both the cases. So for the first one, when I apply, outside we have 1 by pi, u v1 is x into sin nx by n, minus u dash is 1, v2 is minus cos nx by n square, and u double dash is 0, so we can stop it here. And the second part is already function 0, so the entire term is 0. And coming to the third part, again 1 by pi, we have u v1. So u is x minus pi by 2 into v1 is sin nx by n, then minus u dash, which is minus 1 into v2. v2 is minus cos nx by n square. And we have the limit for the first one from minus pi to 0, the last one from pi by 2 till pi. So we applied the limit. Now we are going to substitute the limits. When I substitute the upper limit, the first part we have 1 by pi, there is an x, so it is 0. Second part will become plus 1 by n square because cos 0 is 1. When I apply the lower limit, sin n times of pi will be 0, and this will become already, both the minus become plus, and cos pi will become, actually this is cos n pi by n square. Similarly, coming to the next part, when I substitute the upper limit pi here, sin n pi is 0, and this will become plus, so cos n pi by n square we have, minus, when I put lower limit pi by 2 here, this is 0, and cos n pi by 2 is also 0. So multiples of 90 degrees 0. So everything is 0 here. So we left with, actually it is not 0, it is only odd multiples of 0. So it's better we can write that lower limit as cos n pi by 2 by n square. Now we can take 1 by pi common throughout. So this is 1 by n square minus cos n pi by n square plus cos n pi by n square minus cos n pi by 2 by n square. So we can cancel positive negative terms, and n square can be taken common. So pi n square, and here we have 1 minus cos n pi by 2. So finally the value of an we got. Now as a next part, we are going to proceed with finding bn. So bn, again by formula, it is 1 by pi integral minus pi to pi f of x into sin nx dx. And this again we are going to split into three parts. First part is 1 by pi integral minus pi to 0, the function value is x, and we have sin nx dx. Second part is function is 0, but still we have to write 1 by pi 0 to pi by 2, 0 into sin nx dx, and third part is 1 by pi integral pi by 2 till pi f of x is x minus pi by 2 into sin nx dx. Now once again we are going to use Bernoulli's formula for this. This is u and v. U is x, v is sin x, u dash is 1, u double dash is 0, v1 is minus cos, actually it is sin nx, so minus cos nx by n, and v2 is minus sin nx by n square. In the same way, here this is u and v, so u equal to x minus pi by 2, u dash is 1, u double dash is 0, and v is sin nx, v1 is minus cos nx by n, and v2 is minus sin nx by n square. And Bernoulli's formula is u v1 minus u dash v2 plus u double dash v3 minus dot dot dot. So coming to the first term, we have 1 by pi and u v1. This is u, this is v1. So it is minus, actually there is a minus sign here. So I write minus x cos nx by n. Then minus u dash v2, product of this, already there is a minus, will become plus sin nx by n square. And third term won't be there. And coming to the next part, again u v1. So minus of x minus pi by 2 into cos nx by n. Then we have u dash, this and v2. So already there is a minus, so we make it as plus sin nx by n square. And this is a limit from minus pi to 0, and this is from pi by 2 till pi. When we substitute the upper limit for first term, there is an x, so first term is 0, there is a sin, so second term is also 0. When I substitute minus pi for this, minus of minus pi, it will become plus pi into cos n pi. Even if there is a minus sign inside the cos, it is ignored by n. Sign of multiples of pi will be 0. So only this much we have. Then coming to the next part, plus 1 by pi. When I substitute pi, this is pi minus pi by 2 into cos n pi by n, and sin n pi is 0. Coming to the lower limit, when I substitute pi by 2 for this, pi minus pi by 2 is 0, and for sin pi by 2 it is n pi by 2. So we have sin n pi by 2 by n square. So we completed the limits. Now further rearranging, we multiply this 1 by pi inside, so 1 by pi into pi, and cos n pi is minus 1 whole power n by n. So we can cancel this, then plus, and there is a minus sign also here for the first term. This by taking LCM minus pi by 2, so 1 by pi into minus pi by 2 into minus 1 whole power n by n. And this one as it is minus 1 by pi into sin n pi by 2 by n square. And here we can cancel this pi and pi. So finally we have minus of minus 1 whole power n by n minus 1 by 2, numerator minus 1 whole power n and denominator n, minus 1 by pi sin n pi by 2 by n square. So here this is minus 1 and minus 1 by 2. So minus 1 by 2, by taking LCM we get minus 3 by 2. So combining it as one term, Bn will be minus 3 into minus 1 whole power n by 2n, and this is minus 1 by pi into sin n pi by 2 by n square. This is what our Bn. So now we substitute this in the Fourier series expansion formula. F of x equal to a0 by 2 plus summation n is equal to 1 to infinity an cos nx plus summation n is equal to 1 to infinity bn sin nx. So f of x becomes a naught by 2. The value of a naught we got is minus 3 pi by 8. So now when I divide by 2, it becomes minus 3 pi by 8 and denominator there will be 2 plus summation n is equal to 1 to infinity an. An is 1 by pi n square 1 by pi n square minus we have cos 1 by pi n square into 1 minus cos n pi by 2. So let's write it separately. 1 by pi n square bracket open 1 minus cos n pi by 2. Then plus summation n is equal to 1 to infinity. We have bn, that is minus 3 into minus 1 whole power n by 2n minus 1 by pi into sin n pi by 2 by n square. So here we can, by rearranging this, we are finally getting f of x equal to minus 3 pi by 16. We can take 1 by pi common, which is constant. Summation n equal to 1 to infinity. We have 1 minus cos n pi by 2 by n square. Similarly, here if we want, we can take 1 by pi common. Then we have to multiply this into pi and this into pi. Then only 1 by pi can be taken common. So directly we can take minus 1 by pi common because both the terms are negative. So minus 1 by pi summation n is equal to 1 to infinity. After taking this pi common, we left with minus 3 pi into minus 1 whole power n by 2n. Actually minus is taken out, so it is only plus. Then plus sin n pi by 2 by n square. And we should also write this cos nx and sin nx term, which I forgot to write it here. So I will write it now. Here it will be the whole term into cos nx and this whole term into sin nx. So I will complete it here also. This is cos nx and this whole term into sin nx. Thus we got the final term in the Fourier series expansion for the given function f of x.